Dear students of class 10, so today I will discuss refraction through convex and concave lens, how images are formed. First of all, what is the difference between convex and concave lens? Basically, a lens is a part of a refracting medium bounded by two spherical surfaces or one plane and one spherical surface. So convex lens is thick at the middle and thin at the edges. Concave lens is thin at the middle and thick at the edges. So this is the difference between convex and concave lens. Now a few definitions. Now since there are two refracting surfaces, spherical refracting surfaces, so there will be two centers of curvature, C1 and C2 for both the lenses. A line passing through C1 and C2 is known as principal axis, and there is a point inside or outside the lens through which any ray of light passes through the lens undeviated. So through this point a line or ray of light passes undeviated. This point is known as optical center. So optical center is a point through which all the rays after refraction passes undeviated. That is, their direction doesn't change. Then there is principal focus. Principal focus is a point on the principal axis where the rays after refraction through the lens actually meet or appear to meet. This diameter of the lens is known as its linear aperture, and it has two radii of curvature R1 and R2. So these are some definitions of some terms which are used in drawing ray diagrams of lenses. Now first we take convex lens. Number one, where O lies at infinity. So when object lies at infinity, then this is the convex lens. Simply you draw. This is the principal axis. If object lies at infinity, it means rays are coming parallel, and after refraction through convex lens, they will get focus at a point known as principal focus. So it means when object lies at infinity, after refraction, image will be at principal focus, and it is real. Now when object lies beyond 2f, 2f means twice the focal length. This is the principal focus. So this distance fc is called focal length of the lens, and twice the focal length of lens is known as 2f. So when object lies beyond 2f, then you have to draw two rays to make the image. Ray which is parallel to principal axis always passes through the principal focus, and the ray which passes through the optical center C of the lens passes undeviated. So these two rays meet at this point. This is a point of intersection which lies between f and 2f when object lies beyond 2f. So A dash B dash is the real image of the object AB. So when object lies beyond 2f, image formed is real, inverted and smaller in size, and the position of the image lies between f and 2f. Then when object lies at 2f, now we are approaching toward the lens. When object lies at 2f, again the ray which goes parallel to the principal axis passes through the focus. Another ray which passes through the optical center passes undeviated. So these two rays meet at this point. So A dash B dash is the image formed by the object AB. So you can see the image formed is at 2f. But when object lies at 2f, image is also formed at 2f. Moreover, image is real again, inverted again, but of equal size. Now when object lies at 2f, image formed is real, inverted and of equal size, and position of the image is at 2f. Similarly, when object lies between F and 2F, so object AB lies between F and 2F, one ray which passes through the, which is parallel to the principal axis, passes through the principal focus after refraction through lens. Another ray which passes through the principal optical center goes undeviated. So these two rays meet at this point, that is beyond 2F. So A dash B dash is the image formed by the convex lens when object lies between F and 2F. So image formed is beyond 2F. And we can see image is real, inverted and larger in size. Now size has increased. Real, inverted and larger in size. The region of image is beyond 2F. When O lies at F, when object lies at principal focus in front of the convex lens, then ray which goes parallel passes through principal focus after refraction. Another ray which passes through optical center goes undeviated. So these rays goes to infinity. So it means image will be at infinity. So when object lies at principal focus, image will be at infinity. So there are 6 cases in case of convex lens. It means nature and position of the image formed in case of convex lens depends upon the distance of the object from the lens. So image is sometimes real, sometimes inverted, sometimes smaller in size, sometimes is bigger in size. The last 6th case, when object lies between F and C. This case is very important. So F and C, AB object lies between principal focus and optical center. Then the ray which goes parallel passes through principal focus. Another ray which goes through optical center passes undeviated. But these two rays appear to be coming from the same side on which object lies. So they appear to be coming from this point because they are diverging. So they appear to be coming from this point. So A dash B dash is the image formed when object lies between A and C on the same side. So this means image formed is erect, larger in size and virtual. So image formed is virtual. So this property of the lens make it as a magnifying glass. So it magnifying glass when object lies between F and C. So image is erect and enlarged in size. Then we come to concave lens. So there are 2 cases. Number 1, when object lies at finite distance. So finite distance, this is the concave lens, focus, finite distance and distance AB. AB object lies in front of the lens. One ray parallel goes in this way because it is a diverging lens. Concave lens is also called diverging lens. Convex lens is called converging lens. So this ray appear to be coming from principal focus. Another ray which passes through principal optical center on the principal axis goes undeviated. So these 2 rays meet at this point. So A dash B dash is the erect, virtual and smaller image of the object AB. So A dash B dash is the image formed after refraction through concave lens when object lies at finite distance. So image formed is virtual, erect and smaller in size always. When O lies at infinity, so rays coming parallel gets refracted, but they appear to be coming from the principal focus. So image formed is at principal focus. So in both the lenses, convex lens and concave lens, image formed when object lies at infinity is always at principal focus. So in case of concave lens, the rays appear to be coming from the principal focus, that is image formed is virtual. In case of convex lens, image formed is also at focus when object lies at infinity. So the rays actually meet at principal focus. So this is all about refraction through convex lens and concave lens. So in next video, I will discuss magnification of mirrors and lenses, as well as I will discuss mirror and lens formula. So till then, stay tuned, be happy and